Okay, here's a problem. If the events A and B are independent, with the probability of A equals 0.3 and the probability of B equals 0.4, then the probability that both events will occur simultaneously is select one of the following. Now, if for instance we choose as an example of this is the probability that you're at a certain coffee shop, say between 2 and 3 on a Thursday, is got, say, 0.3. There's a 30% chance that you will be there. There's a friend of yours that's completely independent of you, and the probability that they are there is 0.4. What is the probability that both of you will be there? Now, if you use the notation that is generally used, probability of A intersect with B equals, and that's the probability of you being there times the probability that the other person is there, and that is 0.12. Another way to look at it is if you use a Venn diagram type of technique where the probability of this occurring is 0.3. This whole area here is 0.3, and this whole area here is 0.4. What is this area here, which is the intersection? And that is 0.3 times 0.4, and that is 0.12. Yeah, if this were, so this is the way to understand it. So the thing that we're talking, the first thing you need to identify is if they're talking of probabilities like this, it's called an intersection, and this is how you will do the intersection. If you look at the generalized ideas, probability of A intersect with B equal the probability of A occur on its own times the probability of B. So that is the formula. Maybe I should just clarify, there's different notations. So the probability of A is actually shorthand for probability of A equals some value. Okay, so this and this is the same thing, just written differently. I don't know what much more to say about this one.